So in this video here, we're going to learn how to solve linear systems of equations by graphing. And to start us off, let's start with just checking solutions. So it says here, check whether the given order pair means coordinates, so a pair of x and y values, is a solution to the system. Now first off, let me explain what systems are. Systems of equation is talking about a unit of equations. So you have two equations here, so you have a system of equations. And in this systems of equation, it has both x's and y's. So you might recognize this format. This is what we call standard form for linear equations. Standard form means that the x and y's are both on one side, whereas the numbers are on the other side, or the constants on the other side. So that's a little bit of background. But what we're trying to check for is that this x value, let me change the color here, this x value and this y value, if we were to plug them in, do they actually give the value that's on the other side? So we're going to test this out with the first equation. So I'm going to plug in my x, which is 6, and my y, which is -1, and I'm testing if it actually equals 25. I don't know if this is true yet, so I'm going to put like a little question mark on the equal sign, because I don't know if it's true. So 4 times 6 gives me 24. Two negatives make a positive, equals 25. Now 24 plus 1 does equal 25, so they do equal, so this is good. We're going to check the second question now. And so again, I'm going to plug in the 6, my x value, and I'm going to plug in my y, which is the -1. So I'm plugging in the same x and y values and checking to see if it does equal the right-hand side. So I'm going to multiply these two numbers to give me -18. And if I multiply -2 and -1, I get a +2. And so when I look at this here, I can see, okay, -18 plus 2 is -16. And so both sides equal each other. So this is also true. Since both equations, when I plugged in my x and y's worked, this is a solution. So I can say, yes, it is a solution. Now let's pretend for a moment that when I plugged x and y into the first equation it worked, but when I plugged into the x and y, the second equation didn't work. Then that is no solution. If just one equation fails, it's no solution or not a solution. All right, let's try out B here. So for B, let me grab there we go. So for B here, we have x as -2 and y as -8. So plugging this into the first equation here, that's going to be 2 times -2 minus y, which is -8, equals 52. So if I multiply these two together, -2 times 2 is -4, plus 8, two negatives make a +8, equals 52. Last time I checked, -4 plus 8 is +4. That does not equal 52. So they do not equal, which is why I have an equal sign with a slash in it. That means it does not equal. So because already the first equation failed, I'm not going to go check the second equation because one of them already failed. So that means this is a no solution or not a solution. It's probably more grammatically correct. So it's not a solution. All right, and that's how you check if an ordered pair is a solution to a system. But now let's get into solving a system of equations. So what I mean by that is, let's say you're given an equation and you're trying to find the coordinate that makes it a solution. That's what we call solving a systems of equation. And there's 3 ways you can do it. Today, you're going to learn the first way, which is by graphing. So when you graph, the key to it is you're going to using a graph, you can find a solution for 2 linear equations. So linear equations are equations that look like a line, kind of like these guys here. And what you do is you see where they intersect. So when you draw 2 lines or when you graph 2 lines, you're going to see where they intersect, and that coordinate they intersect at is the pair of solution that you have. So to do this, there are 3 steps you need to make sure you do. The first part is to solve for y. It's easier to graph an equation if you have it as the y by itself in the y mx plus b format or the slope-intercept format. And then once you have y by itself, you're going to graph both equations. So you should be using the slope and the y-intercept to help you do that. and then you're going to find the points, or points in plural, where the two lines intersect. Sometimes there could be multiple places they intersect, and I'll show you what I mean. All right, so let's see the 3 types of solutions that you can get when you have linear systems of equation. So if you're given 2 lines and they just happen to intersect, they'll usually intersect in one location. If they intersect at one point, this is one solution. Now, if you're given 2 lines and they happen to be parallel lines, then, well, parallel, they never touch each other. They never cross paths. So if they're parallel to each other, there are no intersections, so it is no solutions. And so the last one here, you can see whenever you have an equation that actually turns out to be the same lines, so sometimes you'll get 2 equations, and when you graph them, you realize they are the exact same lines, and they'll be graphed on top of each other. Well, if that's the case, then what you have here, if they are on top of each other, they're going to intercept at any given x and y values. So that means that there's an infinite many possible solutions. So if they're the same lines and they're graphed on top of each other, this is infinitely many solutions. And I'll try to show you each one of these cases here in the practice problems. So let's start with example 1 here. So in this part here, you can see that we are given a systems of equation, 2 equations, and we're asked to figure out or estimate the solution. So we're going to figure out where do they cross and intersect? What coordinate do they intersect at? And so I'm going to use some colors here just to help us out with keeping track of all these equations. So let's call this equation 1 and this one equation 2. So for equation 1, remember the first step, if you read in the directions, is to solve for y. You got to get y by itself. So let's go ahead and do that here. So my first equation, I'm taking 2x plus y equals 6. And I'm going to try to get this y by itself. So I need to move over the 2x. And I do that by subtracting 2x over. So that cancels. Y drops down. And notice that these are not like terms. 6 is a number. 2x is a variable. So in this case, I'm just going to write 6 minus 2x. I'm going to bring the terms down. And now y is by itself, and I also want you to notice I have the y-intercept now, and I have the slope. So my y-intercept is b, which is 6, and my slope here is negative 2 over 1. So if I were to graph this, I need to graph it at 6, which is all the way up here, and then my slope here, I have to go down 2 over 1. And I'm going to do this multiple times, so that way my line is accurate and it also helps me see where it intersects. So I'm going to do this multiple times until I cover the graph. So I'm going to go down 2 and over 1 until I have all the points covered. Usually we only need to graph 2 points, but in this case, try to graph all the points so you can make this line as accurate as possible when you try to find an intersection. So now I'm going to do it for the second equation. So I'm writing the second equation, 3x 2y equals 2. I'm going to try to get y by itself. So I need to subtract the 3x over. Cancels. And so now you have 2 minus 3x. So I'm going to divide by negative 2. And when you're dividing, you need to divide every term by negative 2. So this gives you negative 1. If you divide negative 3 over negative 2 is a positive 3 over 2x. All right, so we can see here my y-intercept is at negative 1, and my slope here is at 3 over 2. So if I plot this on the y-axis, I'm going to plot it right there at negative 1, and my slope here is going up by 3 and over 2. And so notice when I do that, I hit it right there. Let me use a different color here. So right here, it looks like my interception, but let me draw all my coordinates. So I'm going to go up 3 over 2. That's the furthest I can go. And down here, I can go down 3 and over to the left 2 to go the opposite direction. And then that's pretty good for my line. So there's definitely one intersection here. So what I can say that this is one solution because there's only one interception. And you can see that is at 2, 2. So I write 2, 2 as my solution. So when x equals 2 and y equals 2, that is where the lines intersect. And I'm done. So let's try that for the next one here. So for part B, I need to graph this equation. But again, I need to try to get y by itself. So I'm going to color code this, make this 1, 2. And so for the first equation here, I have negative x plus 3y equals 3. So I'm going to try to get this y by itself. So I might want to move over the x by adding it over. So if I add x over, that cancels. And so I'm left with 3y equals 3 plus x. These are not like terms, so you just bring them down as they are. And now I have to divide by 3 to every term. And so that leaves me with y equals 1 plus. Now this guy here, notice that you're dividing by 3, and I'm going to try to write this like as a slope. So if I look in front of this x, it's technically a 1 in front of the x. So I can write this as 1 over 3 and then x to the side. I like to write it this way so I can explicitly see what the slope is. And so my slope here is 1/3. My y-intercept here is 1. All right, so going ahead and plotting the 1 on the y-axis, and my slope is 1/3, so up 1 over 3 to the right, up 1 over 3, or you can go down 1 over 3 if you're going the opposite direction, down 1 over 3. And so if you connect the dots, you have your line. All right, let's draw our next one here. So for the second equation, we have 2x minus 6y equals negative 6. So I need to subtract 2x over to try to get that y by itself. And so they're not like terms again, so I'm just going to bring them down as they are. I'm going to divide by negative 6 to every term. So that cancels. Y equals positive 1 because negative 6 divided by negative 6 is positive 1. These two are also negative, so that makes a positive. 2 over 6 can be reduced to 1/3, right? Because 2 goes into 2 one time, 2 goes into 6 3 times. And so now I have my equation. And so my slope here is 1/3, and my y-intercept is 1. Hey, wait a minute. Isn't that what I got before? Wait a minute. These two are the exact same equation. So if I were to graph this, it would kind of be redundant because they would be the exact same equation. This equation is sitting on top of the first equation. So because they are the same equation, you might remember me saying, if you go up here for a sec, anytime they're the same equation, because they sit on top of each other, there's an infinitely many amount of solutions. So guess what? We have infinitely many solutions. So I'll just write that here. Infinitely, because they're going to touch everywhere. So there's an infinite amount of interceptions. All right, so I'm going to go into the next one here. I'm going to go ahead and do the practice problems for this one. I don't usually do the practice problem in a video, but I think it's good practice. And so free bonus points for you guys if you watch this video. Make sure you show your work when you're doing practice problems too. So again, they want me to sketch the graph, and I'm given two equations, so I need to start by trying to get y by itself. So if I take one, bring it down, and start solving, to get the y by itself, I need to move the 3x over. So I need to subtract by 3x. Cancels. Negative y comes down. This is going to be 5 minus 3x. I need to get rid of the negative, so I'm going to divide by negative 1. Because technically this is a negative 1 in front of y. So if I divide by a negative 1, this will cancel. Y comes down. 5 divided by negative 1 is negative 5. Negative divided by negative is a positive. Now 3 divided by 1 is 3, so this is just 3x. So once I have this, I can see my slope here is 3 over 1. my y-intercept is -5. So if I go to the graph here on the y-axis, I need to go to -5. I need to go up 3 over 1. And I'll just keep following that pattern. So up 3 over 1, up 3 over 1, and connect the dots. Hopefully this graph will intercept with the other graph. So the second equation has -x plus 3y equals 9. So I'm going to add over x to both sides. That cancels. 3y comes down. 9 and x are not like terms, so I'm just going to bring them down as they are. Need to divide over 3 to try to get the y by itself. And so y is equal to 9 divided by 3 is 3. This 3 is dividing by this x, and technically the x has a 1 in front. So this is going to be 1/3 x. So my y-intercept here is 3, and my slope here is 1/3. So if I go to this graph, if I plot it at 3 here, and I go by 1 and 1/3, I go up 1, up 1, sorry, a little bit of glitch here. So I go to 3, up 1 over 3, and then I would hit it right here. And try to make this graph look nice. So it looks like I have one intersection right here, and that intersection looks like it's at 3, 4. So I have one solution because there's only one intersection at 3, 4. All right, last one but not least. This one here, notice that the y is already solved for us, so it looks like an easier problem. So the first one here has y equals 5x. So if I were looking at it, I can tell that the slope here is the number in front of x, which is 5. So my slope is 5 over 1. Notice that there's not a y-intercept here. There's not like a plus a number or minus a number. So that means you don't have a y-intercept. So the y-intercept starts at 0. So if there's not a y-intercept there, then you assume it's 0. Because if you were to say plus 0, then that's redundant. You wouldn't even need to write that. So my y-intercept's at 0, so I go to 0 and plot. And my slope is up 5 over 1. Or you can go down 5 over to the left. All right, and so now I have my graph here. I'm going to graph the second one here. I want you to notice that the second one equation has a y-intercept of 4, and the slope here, the number in front of x, is 1. So if I go to the x-axis here, and I go to, sorry, not the x-axis, the y-axis, I go to y equals 4, and use the slope, which is 1 over 1. I go up 1 over 1. I already hit it right there. And so in this case, here is my only intercept, which is going to be one solution. And that is going to be at 1, 5. Make sure you write your x, then your y value. And that's it. So that's it for this video. I hope you found it helpful. If you have any questions, let me know. And that's all for this video. Bye, guys.